Greetings to all, and welcome to this video where we will explore in detail Vector Calculus course. This course is designed to provide you with a solid foundation in understanding vectors, their properties, and their applications in various fields such as physics, engineering, and computer science. As for the plan we will use to present our course, Vector Calculus. First, we will begin our presentation by distinguishing between scalar and vector quantities. Next, we will delve into the definition of vectors. Following our discussion on vector definitions, we will focus on unit vectors. Finally, we will cover the various operations that can be performed on vectors. Starting by scalar and vector quantities. Physical quantities can be classified as being scalar or vector quantities. Scalar quantities are those quantities which are having only magnitude, but no direction. Examples: mass, length, density, volume, energy, temperature, electric charge, current, electric potential, etc. In contrast, vector quantities are those quantities which are having both magnitude as well as direction. Examples: displacement, velocity, acceleration, force, electric field intensity, magnetic intensity, etc. Next, we shall examine the definition of vectors. A vector is a quantity that has both direction and magnitude, and it can be denoted by the symbol vector v. A vector can be represented graphically as an arrow, where the length of the arrow indicates the magnitude and the direction of the arrow indicates the direction of the vector. After investigating vector definitions, we will examine unit vectors. A unit vector is a vector with a magnitude of 1, and it is used to indicate direction without concern for magnitude. Dividing off vector by its magnitude results in a vector of unit length, which can be expressed with the following formula: vector u equal vector v divided by the magnitude of the vector v. For example, we have vector v equal to 4 vector u. We can define a number of operations on vectors geometrically without reference to any coordinate system. Here we define addition, subtraction, and multiplication by a scalar. We will also cover the dot product and cross product. Starting by vector addition. Vectors can be added. We define a new vector r equals vector v1 plus vector v2, the vector addition of two vectors by a geometric construction, which can be done using triangle method or the parallelogram method. The sum of two, or more, vectors is often called the resultant. As for triangle method, head to tail. First, draw the arrow that represents vector v1. Second, place the tail of the arrow that represents vector v2 at the tip of the arrow for vector v1. Finally, the arrow that starts at the tail of vector v1 and goes to the tip of vector v2 is defined to be the vector resultant r. And for the parallelogram method, there is an equivalent construction for the law of vector addition. The vectors v1 and v2 can be drawn with their tails at the same point. The two vectors form the sides of a parallelogram. The diagonal of the parallelogram corresponds to the vector r. This results can be generalized to a larger number of vectors. Vector addition satisfies the following four properties: commutativity, associativity, identity element for vector addition, inverse element for vector addition. Second, vector subtraction. We define subtraction as addition with the opposite of a vector as present in the following formula. As you can see how the vector w in the figure is equal to vector v1 minus to vector v2.
Next operation on vectors is scalar multiplication. Vectors can be multiplied by real numbers. Let v be a vector. Let alpha be a real number. The multiplication of vector v by alpha is a new vector, which we denote by the symbol v/equals alpha multiply by vector v. Let alpha greater than 0, then the direction of alpha v is the same as the direction of vector v. The direction of minus alpha v is opposite of vector v, as showing in the figure below. As for geometric definition of scalar product, also called the dot product, of two vectors a and b is defined as scalar product of vector a and vector b equals magnitude of vector a multiplied by magnitude of vector b multiplied by cos theta, where theta is the angle between the vectors a and b, as showing in the figure. As for geometric definition of the vector product, also called the cross product, of two vectors, say a and b, is equal to another vector c perpendicular to the plane containing a and b, defined as follows. Vector c equals magnitude of vector a multiplied by magnitude of vector b multiplied sin theta, as showing in the figure. The mixed product, or triple scalar product, is the dot product of the first vector with the vector product of the other two vectors.
We are coming to the end of this video. Thank you for having devoted time to viewing it.